everybody say hi, Kelsey.
Hey, Michael.
Hey, Kelsey. 5-1. Okay. The tests were not great, Kelsey. Come see your test. Yours was not bad, I don't think, really. But the tests were not great. So I told everybody this is a fresh new start. This stuff will show up on the semester test, even though we won't get done with chapter 5. We'll probably get like maybe 4 sections done by next week when we start. Those sections are going to be on the semester test. Typically, exponential functions are not bad. You want those questions on the semester test because those you'll answer and you can do those.
What kind of questions are they?
Exponential functions. We're going to be doing exponents today, okay? So, talking about roots and such. Let's just go down to example 1. Let's go straight to example 1. We'll go. Operations with exponents. Simplify each expression. Part A. Let's figure out what you do. 8 and the square root of 8 and the square root of 12. What can you do?
8 multiply.
Can you put 8 and 12 together?
Yeah, they both are under a square root.
Right, and you're multiplying. If you were adding, you could not, right? If this was the square root of 8 plus the square root of 12, nope, can't do it, right? But the square root of 8 and the square root of 12 times each other, you can. 96. What's 8 and 12? 96, okay? But you're not going to leave your answer as the square root of 96, and you're not going to give me a decimal.
Are we going to have to
You're going to have to break it down. So 96 breaks down into something.
48.
48 and 2. You can't take the square root of 48, you can't take the square root of 2.
Sorry, I was doing
I don't know.
adding.
No.
3 and like
31.
12
3 and 32.
32.
You can't take the square root of 3 and you can't take the square root of 32. 4 and 28.
You can
No,
do
20
that.
something.
You can take the square root of 4.
Think bigger than 4.
8.
If 4
9.
works, I always check
16.
16. If 4 works, I always check 16. Does 16 go into 96?
Probably.
16 times
Yes,
7.
it does. Sarah.
Right?
16 and
4.
6.
Okay.
16 and 6. Okay, 16 goes in there 6 times. So if I take the square root of 16 and the square root of 6, this would be 4 square roots of 6. Yeah, happy with that? Do we know how this works? Like, these aren't hard, right? Give us a ton of these. Put these on the semester test because we can do these, right?
Yeah.
Put these on the semester test. Okay, let's go to B. Okay, minus. We said we can't add and subtract, but can you make them broken down look nicer? Like the square root of 12, does he break down?
3 and 4.
3 and 4, so let's go 4 and 3.
So 2 square
Okay.
root of 3.
So square root, this is 2 square roots of 3, okay, minus 75 breaks down
4
into
and 25.
25 and
3.
3. So this is the square root of 25 square root of 3, which is
So 5 square root of
5 square roots of 3. What is 2 square roots of 3 minus 5 square roots of 3?
Negative 3.
Negative 3.
Negative 3 square roots of 3. It's just like adding x's together, right? 2 minus 5 is negative 3. Make sense? Happy with this?
The square roots have to be the same for subtracting.
Yes, adding and subtracting the square roots have to be the same. So you couldn't take like 2 square roots of 4 and 5 square roots of 3 and put those together. They have to have the same behind, right? Yes? What was your question, Sarah?
Well, that was my question, but now I have another one. When you try and break it down, they don't come out the same. Then you just
leave it.
Okay.
Yep, you just leave
so
it simplified.
You can add.
What?
You can add if they break down.
As long as they're the same when they break down, right? Like if it was 2 square, let's do this. 2 square roots of 4 minus 5 square roots of 3. That's your answer, right? There's nothing you can do with that. So you break it down. If they have the same base, then you can put them together. But if they don't, that's the final answer, right? Okay, I'm going to get rid of that so it doesn't look weird on the notes, okay? All right, so there's that. Part C.
Divide
Part
the
C, okay? Let's do, I tell my algebra kids when they do this, to break each piece apart. So we're doing the cubic root of 8, we're doing the cubic root of x to the 6th, and we're doing the cubic root of y to the 4th power. Okay, I'll show you how this works, all right?
2.
The cubic root of 8 comes out nicely. It is 2, Emma said. What does the cubic root of x to the 6th power come out, right? This is saying, what do you take times itself 3 times to get x to the 6th? That's x squared, okay? When you are doing exponents, you are dividing. What is 6 divided by 3? 2, x squared, right? You're dividing. Okay, now, does 4 divide 3 nicely? No. So this is one that you have to break down into pieces, okay? Make sense? Good? Okay, what can you take the perfect cubic root of that goes into y to the 4th? Y to the 3rd. I'm going to put 3 over here and I'm going to hang 1 off. That's a total of y to the 4th. Do you see how that works? Okay? Then what is the cubic root of y to the third?
Y.
Just y. What's the cubic root of y?
Just Y.
The cubic root of y. So I've got this piece, this piece, this piece, this piece. And I want to put it all back together. Okay? Put it all back together.
X, Y.
Nope. 2x squared y
Oh.
times the cubic root of y. The cubic root of y didn't come out nicely, right? We still have 1 on the inside. Does that make sense?
Yeah.
Okay, you do as much as you can pulling them out.
I can't no.
Okay?
Yeah, I agree.
Yeah, those ones are ugly.
Yeah.
Okay, good? Happy with that? Does it make sense though? Okay, there's that guy. All right, D. What are they asking you to do on this?
Multiply foil.
Foil, multiply. Okay,
Wait.
what is this and this? Do you see that?
Oh, they're the conjugates.
They're conjugates.
So
Okay,
the
what's gonna
square goes
happen?
away.
You're gonna get a number.
You're gonna get not a number because there's a variable there, but you would if there was like eyes and stuff in there.
The
Okay.
middle pieces
So
are
the
gonna
middle
go away.
people pieces are gonna cancel out because this are
And-
conjugates. Okay.
and then
So
it's
hold
just
on, hold on,
ABC.
hold on, hold on.
At the end.
Nope. Just wait. Okay. So let's FOIL. 5 and 5 makes
25.
25. 5 times negative c
Minus 5.
minus 5 square root of
Plus
c.
5c.
Okay. Then the inside pieces
5 squared.
is positive 5 square root of c. Okay. And then the square root of c times negative square root of c.
It would just be the
First of all is negative.
Yeah, it's just negative.
What's the
Square root-
square root of c times the square root of c?
C
Negative
squared.
C.
Like square root of c times the square root of c
Would just be C.
would just be c. This is like the
25
square root of
minus
c
c.
squared, right?
Hey, I said that.
25 minus c.
So it's just like that, right? Do you see how that comes out? The square root of c times the square root of c is just c, right?
Yeah.
Okay? All right, these two cancel out, so it's just 25 minus c, and that's the solution. Good? Happy with that? Why do they say where c is greater than 0?
Because
Because
it can't
C
be
can't be
negative
zero.
inside
Right,
the
c
square root.
can't be negative. So they're not trying to fool you with doing that. They're just trying to say, like, you don't have imaginary numbers, so don't worry about the imaginaries. Make sense? Good?
Yeah.
Okay, let's go down to this one. Use a calculator to approximate. Okay, before we do a calculator, just wait a second. Just wait a second. There are 2 ways of plugging this into your calculator. You can literally put it in as 40 caret 1/5. You might have to write it in parentheses like that. You can literally do it that way, or however your calculator does it.
Or
But
1 over
40
40.
times 5 over.
no. That's different. That's
40,
negative exponents.
the-
Okay, what does the 1/5 power mean? This is like a really important thing.
Fifth root.
This means the 5th root of 40, right? Anything to an exponential power or whatever, to an exponent that has a fraction, it's that root, okay? So this is the 5th root of 40. Okay, I want you to practice typing in both ways so you know. All right, so type in 40 to the 1/5 power. Try that and see what you get.
2.09.
2.09 is what you should get. Check and make sure that you do. Try practicing
How do you
typing
put
that in.
decimals?
Okay, what do you mean?
How do you put not decimals, how do you put fractions?
Fractions, I just open up a parentheses and say
Alpha.
1 divided by 5.
Oh, alpha y equals enter.
You could do alpha y equals enter.
So we're gonna have a test over like this chapter.
The sections that we get
2022?
through, what do you mean? Oh, we're going to have a test over this chapter? Not until January.
So we
But
review
this
these
stuff is going
lessons
to,
right
yes,
when we go.
yes,
When do we
yes,
get off for
we do.
break?
21st.
The 21st, Monday,
Wait,
Tuesday.
how do you do the second one?
Okay, how do you do the second one? How do you do this one where you're doing the 5th root?
It's like a week and a half.
Exactly.
Do you know how to do the 5th root?
Oh,
Okay, here's the deal.
math 5.
Okay, write this down. When you're doing the 5th root, you have to type 5 in. Okay, so type in 5 and then you hit the math button and you go down to where it
It's
says
also 5.
X, this guy.
It's also 5.
Is it 5? Okay, so go 5 and then go to the math button and go to that square rooty thing and it'll put that in there and then you type in 40.
5 math 5.
Okay, there it is. Type it in. It should end up being 2.09. If you need
Well, we're
help,
supposed
let me
to-
know.
Hey, we're supposed to approximate each expression to the nearest 10,000.
Oh, 10,000. Which one's 10,000? Places.
2.09.
20913.
13. 2.0913. There you go.
These. Can we do more of these?
Because you did it
Okay.
square root of 50.
All right. This one is to the 1/11th power. Okay. So you can literally type in 225 to the 1/11th power, or that is the 11th root of 225. We're going to go 4 decimal places.
But do you want us to round on the floor?
Yes. Yes. Yes.
1.6362.
1.6362 is rounded. 4 decimal places? Yeah? Okay. I'm going to add one more thing off to the side over here, so just wait a second. What if they say, like, I'm going to go, let's go 28 to the 2/3 power. Okay? 28 to the 2/3 power. What does that mean?
Type her in.
You can type into the 2/3 power, but what does the 2/3 power mean?
The cubic root.
It's the no. So it's would be either the cubic root squared or the.
Is it the cubic root squared or is it the square root cubed?
Squared divided by 3.
It's the square
Okay,
root
look
cube.
over here. The 11 was on the bottom, right? And that's my root, right? 11. So which root are we going to use over here?
To the cubic root.
3 goes here
squared.
and 2 goes here, right?
Oh, that's dumb.
So you can take 28 squared and the cubic root of that. Or this is actually the same thing as the cubic root of 28 squared. It doesn't matter which order you go in. Does that make sense? Okay? So your bottom number is always your root. Your top number is your exponent. Root, exponent, root, exponent. Okay? Good? Happy with that?
Yep.
All right, let's go down and
Type it in. Can you type it in like this?
you can type it in caret 2/3.
How much more time do we have left?
That's totally fine. Totally fine. 15 minutes. Okay, here we go. Let's go down to, I don't know. Let's go, oh, heavens to Betsy. Okay, let's go to this laws of exponents. Here we go. Ready? This one, this box.
No.
I'm going to give you some examples of these rules, okay? So here's an example of number 1. Let's say you have x squared times x cubed. They'll just write them right together. X to the 5th. Versus, I'm going to bump over to like number 3. Let's go down to number 3. X squared cubed. What do you do with those exponents?
Multiply.
Multiply. That is x to the
6.
6th power, okay? Because 3 times. So this is like x squared, right? And that is x to the 6th power, correct? Those mean the same thing. So that's why when you're when they're stair-stepped like this, when they're like that, you multiply those exponents. Here you add them. X to the 3rd power over x to the 7th power.
Subtract.
You subtract the exponents, okay? So 3 x's on top, and I have 7 x's on the bottom.
You're gonna have 4
Okay,
on the bottom.
they're gonna cancel. I'm gonna have 4 left, and they're gonna be on the bottom, right?
So 1
So
over.
1 over x to the 4th power. Does that make sense?
Or x to the negative.
Or x to the negative 4th power. Okay, let's go to here, number 6. I'm bouncing around all over the place.
Wait.
Sorry, folks.
So on that one, it could just be x to the negative 4th. You don't have to put
Okay,
a 1 on
I
top.
think they will do positive exponents. Okay, so let's do this one. Let's say instead we have c to the negative 3rd power over c to the 7th power. Okay, how do you get a negative exponent to be positive?
Wait, where are we
But
writing?
This is number 6. This is number 6 rule. Okay? If it's a negative exponent, you flip it. If it's in the top, you flip it to the bottom. If it's in the bottom, you flip it to the top, right? Okay? So let's say I do this and I flip him to the bottom, and now that is what?
C to the 10th.
C to the 10th on the bottom. What's on the top? 1.
Whoa.
I know with the
Wait,
10
wait, wait,
or with the
wait.
7.
Could you not just go subtract it, go negative 3 minus 7, that's negative 10, and then put.
Yeah. Okay, happy with that? Okay, let's go up to this top part right here. These two rules say this. Let's say I have x squared y to the 3rd, and that is all cubed. What does that make?
X6, Y to the 9.
X6, Y9, right? This guy gets distributed. That's what that rule says.
Let me write that
Okay?
down.
Yeah? That's what that rule says. Okay? That's the exponent rule. Okay? I'm going to do the same thing again. I'm going to say x squared over y to the 3rd to the 3rd. Same thing when you're dividing. You still distribute. And when you're distributing, you multiply those exponents. So x6, y9 on the bottom. Right?
Yep.
You just distribute that square, right? Or
Wait, but
cube
then
or
you
whatever this
have
is.
to- No, they're not the same. They're not the same thing.
Correct. If they were the same variable, you'd have to simplify them. But anyway. Okay, good? Happy with that? All right.
Can we not do example 3?
Woo! Example 3. This is a doozy. I might change some of these because they're kind of ugly, but let's do this one. To the 2/3 power. Okay, we have to distribute the 2/3 power. And the thing that people screw up all the time, they ignore the 8. You have to take 8 to the 2/3 power also. Okay, so this is 8 to the 2/3 power. Leave them like that and we'll fix them here in a second. Don't do it in your calculator. Don't do it in your calculator. Don't do it in your calculator. We're gonna do it here in a second. Don't do it in your calculator. We're gonna do it in our heads. Don't do it in your calculator. Okay, now we've got to take r to the 3/4 to the 2/3. Do we multiply or add?
Molt.
Multiply. So I take 3/4 times 2/3.
6.
Or I can cancel the 3's
1/2.
and cancel the 2 and the 4. That's 1/2, right? It's 6/12 or 1/2. Okay, then I have s. I got a mess here. I have s to the -3. What's -3 as a fraction?
3/1. So
3/1.
2.
So I have 3/1 times 2/3.
-6/3.
S to the -6/3, which is
-2.
-2.
Hey, I
Okay.
said that.
1 over
Yep.
s squared,
Okay, just wait a second.
right?
Okay, let's fix some stuff. So let's start with the 8 to the 2/3 power. That means what root of 8? What numbers go where?
Cubic root, which is 2, squared
Cubic root of
4.
8, I'm going to put the 2 on the outside in this case. The cubic root of 8 is 2, and 2 squared is 4. So this is 4 r to the 1/2 power, but I don't like negative
root of r.
exponents, so I put him over s squared. That's what he is.
What?
Put it all over s squared, or it should
Yeah,
be
All of
you
it's over
flip it
s
to the
squared.
bottom.
You flip the s to the bottom. I put him in the bottom.
So it
Well,
would be
wasn't it
times
negative
1
two?
over s squared. It would be.
I thought it was
Well, okay,
-2.
what is 4r to the 1/2 times 1 over s squared? This is over 1, right?
So if you wrote it like that, it wouldn't be wrong.
Technically, but you want to simplify it because you
Okay.
want to get rid of the multiplication
Yeah.
symbol, right?
Yep.
So that's technically what that's saying. Don't write that down. Anybody, don't write that down.
What?
So there's that. Okay, good. S goes to the bottom, and it becomes positive. Good, good.
Yeah, my
Just wait a
brain
second.
just thinks a little bit differently.
Let's do one more and then we'll stop. Let's do this guy. Okay. All right. What do you do with this?
You foil the X foil.
Take this times that and this times that. Okay. Do you multiply or add?
Multiply.
No, you add.
You add.
Add what?
Add the exponents. 1/2 and 3/4.
So you have
You
to change
add
it to
the
2
exponents.
Why?
Okay.
Why? Yeah.
What?
I agree. Why?
Why? You add the exponents.
Because
Like
it's
if
not
if
to
it's
a
x
certain
squared
power.
times x to the 3rd, you add those
Oh,
exponents,
got
right?
it.
X to the 5th. Those are right next to each other, right? You add. You're adding 1/2 and 3/4.
5/4.
Okay. This is if I put it in terms of fourths, 1/2 is really 2/4. So Emma's right. 5/4 minus 1/2 and 3/2
Is 4/2.
is 4/2,
2.
which is
Squared.
2.
Whoa.
Done?
No. Yeah.
Yeah. I can't put those together.
Jay
JK.
can.
No, you can't. No, you cannot.
You can just put the 2 over.
Okay, let's be done. I made the executive decision that we're done.
That'd be fine. Sure. No. Okay. Sounds good. Okay. All right. Happy with that? Does that make sense?
Yep, we're done.
Okay.
You're done.
Goodbye, Kelsey.